Very good morning, my dear students. I would like to take today's sessions about the buoyancy and flotations. Last class itself, we have discussed so many things. Uh, what are the things we have discussed? The pressure measurement and how do you measure the absolute pressure, atmosphere pressure, and vacuum pressure, and the types of gauges as like deformed gauges, bottom tube pressure gauges, dead weight pressure gauges, below tube pressure gauges. And also we had seen these sample problems in piezometers and differential manometers. Also we have solved the uh, some of the problems, and today sessions we are going to discuss about the buoyancy and flotations, right? First of all, we should know what is mean by buoyancy. So buoyancy is the force offered by a fluid on your body, that is called as buoyancy. The amount of buoyancy depends upon the uh, weight of the body or the volume of the body, right? The buoyancy forces, the buoyancy, when the body is immersed in a fluid, an upward force is exerted by a fluid on your body. This upward forces is equal to the weight of the fluid displaced by your body, is called the force of buoyancy, or simply it is called as buoyancy. For examples, this is the body, so contains some amount of liquid, right? Now I am going to put the one irregular shape body inside the water. What will happen? Uh, the water level will increase. This this is the principle. This is the ideas came from Archimedes principle. This principle, this principle we have studied in lower class itself. Uh, this the extent of this principle that is called as buoyancy, right? So the various applications of buoyancy we will discuss in future forthcoming slide. Next one, center of buoyancy. It is defined. It is the point. The center of buoyancy is the point through which the whole buoyancy forces act. Where the buoyancy forces act, the center of the displaced liquid. Center of the displaced liquid. So buoyancy forces அப்படின்னா எதுக்கு ஈக்குவலாக இருக்கும்? The volume of the displaced fluidக்கு, அதாவது weight of the displaced fluidக்கு ஈக்குவலாக இருக்கும். அந்த buoyancy டோட்டல் buoyancy forces ஒரு பாயிண்டில் தான் ஆக்ட் ஆகும் இல்லையா, அந்த பாயிண்ட்டுக்கு பேர் தான் வந்து நம்ம சென்டர் ஆஃப் buoyancy அப்படிங்கிற சொல்கிறோம். இந்த சென்டர் ஆஃப் buoyancy எங்கே சார் இருக்கும் அப்படின்னு கேட்டிங்கன்னா, ஃபார் எக்ஸாம்பிள் it's a vessel, we are inserting, we are putting uh, one rectangular object inside the water. Inside the water, this is the wood. Okay, this is a wooden material. uh, it is dipped Now see the part of the volume is submerged in water and the remaining volume is exposed to the air. If the weight of the body is higher, what will happen? Directly, this body comes at the bottom due to the higher weight and density. From this, what is the amount of displaced liquid? This amount of liquid will be displaced. This amount of liquid will be displaced actually. So, here the buoyancy forces act where the center of the displaced liquid. This is the center. This is the center. At point this point, the total buoyancy forces F is act. It is called as center of buoyancy. Right. Coming to one simple problem. Uh, Please take down note and write down this problem. Then only we can solve one by one. Okay. Find the volume of the water displaced and positions of center of buoyancy for a wooden block of width 2.5 meter and of depth 1.5 meter when it floats horizontally in water. The density of the wooden block is 650 kg per meter cube and its length is 6 meter. Right, okay. You have to clearly note down and the density of the wooden block is less than the density of water. Right? What is the density of water? Density of water is equal to 1000 kg per meter cube. Right? 1000 kg per meter cube. What's the density of wooden block? 650 kg per meter cube. So the density of water is higher than the density of block. So that's why the body will float instead of submerged in the water. Okay. Now we are going to solve this problem as per the procedure. Please write down the given data. What are the data given? Width, width of the body given. Width of the body W is equal to 2.5 meter and depth T is equal to 1.5 meter and length is equal to what is length? Length is given in the bottom of the problem, right? Yes, 6 meters. The volume. How do you find out the volume of the cuboid? You have to multiply all dimensions. 2.5. 1.5. 1.5 into 6. How do you calculate without calci? 2.5 into 6. The value 15. 15. 15 into 1.5. 22.5 meter cube. Right. Now the density of wooden block is 650 kg per meter cube. How do you calculate the weight of the wooden block? Weight of the wooden block. Weight of wooden block. Weight of wooden block is equal to rho GV. So density is given 650 into gravity is 9.81 into volume. Yeah, we have already calculated. Uh, Multiply these terms, you can get the weight of the block. The value will be 143471. Everyone use calculator, then only you can understand everything. It will be easy for calculating in university examination point of view. Okay, next thing, for equilibrium, the weight of the water is displaced is equal to weight of the wooden block. Under the equilibrium condition, under under equilibrium conditions, under equilibrium condition, weight of the water displaced is equal to the weight of the wooden block. Weight of wooden block is equal to weight of the water displaced. Water displaced. Okay. The weight of the wooden block is already known value. Weight of the wooden block is 143471 Newton is equal to weight of the water is displaced is equal to rho density of water into gravity into uh, volume of the water displaced, right? So now we have to calculate the volume of displaced. So from that we can calculate 143471 divided by density of water is 1000 into 9.81 is equal to 14.625 meter cube. Okay. The volume of displaced, we got the answer. The volume of the water displaced. Yeah, alright. We have the answer. Now we want to find out the center of the buoyancy. We have to find out the center of the buoyancy. How will you find out? First of all, we have to find out the total height, total submerged height of the body in water. Okay. How do you find out the total submerged height? The positions of center of total submerged height, positions of center of buoyancy is equal to position of center of buoyancy Since of center of buoyancy is the volume of wooden block in water, volume of water displaced. We have to equal both things. Volume of volume of water displaced equal to volume of wooden block in water. Right. Okay. Volume of water displaced is known one, that is volume of plus is 14.625 is equal to volume of the wooden block in water is 2.5 meter width and 6 meter length and h meter depth. The h is unknown. From that we have to find out the h value, that is 14.625 divided by 2.5 into 6 is equal to 0.975. This is h value 95 meter, right? 75 meter. Okay, this h value is 0.975. Is the total depth is immersed in water or wooden plank, right? So the center of buoyancy will be located by the centroid of the displaced liquid. The half of the distance By the half of the distance, the centroid will be located. So we have to calculate the center of buoyancy by the half of the height of submerged body. So center of buoyancy is equal to h by 2. H is equal to 0.975 by 2 is equal to 0.4875 meter. This is center of buoyancy. Cb is equal to 0.4875. Dear students, I will minimize this one. Take a screenshot. And the whole problem and solution will be clear to you. Please take the screenshot for the future reference. Okay, thank you. We will see the next problem. Right? Next problem is an important problem. This problem will be asked in most of the competitive examinations and as well as 2 mark questions in university examinations. Uh, I will read the problem. A stone weighs 392.4 Newton in air and 196.2 Newton in water. Compute the volume of stone and its specific gravity. It's a very simple problem and also basics one. Right. Given stone weight in air is equal to 392.4 Newton weight, and in water stone weight in water is equal to 196.2 Newton in water. Okay, what we have to find is equal to volume of stone. Volume of stone. Second thing, we have to find out the specific gravity. Specific gravity. Solution. Solution. The actual weight of a stone is the weight is measured in air, right? So in case of we have measured the stone weight in water. Due to buoyancy, the weight of the water will be less. The I think the half of the weight will be reduced in water because of the buoyancy forces is offered there. This is some amount of weight and take the gradients. Now, by the equilibrium condition, so the equilibrium condition, we have to take the weight of stone in air is equal to weight of stone in water plus weight of water displaced. Weight of water displaced. Now these two things are given. Now substitute here 392.4 is equal to 196.2 plus rho g v. The weight of water is equal to density gravity into volume, that is called as weight of water. Now from that we can calculate the volume of displaced fluid. So uh, 392 4 minus 196.2 divided by rho gv 1000 into 9.81. From that we have to find out the volume. What's the value? Calculate fast and tell the answer. Please. I have 2 minutes of time. You please calculate the volume. So value. Yes, right. The volume is equal to 2 into 10 to the power 4 centimeter cube or 1 by 50 meter cube. Is it right? Okay, fine. Volume of stone is known one. Right. Now we have to calculate the mass of the stone, the density of the stone. So mass specific gravity. Point 81. So now the value will be 40 kg. Mass of stone is known. From that we can calculate the density. The general density formula density is equal to mass per volume. Mass of the value is known. Mass is 40. Volume is 1 by 50. Is equal to 2000 kg per meter cube. Right. Density is known. Now we have to find out the specific gravity. Specific gravity. How do you, what's the formula for specific gravity? Specific gravity of stone. Stone is equal to density of stone to the density of water. Density of stone is 2000 kg per meter cube and density of water is 1000 kg per meter cube is equal to 2. Specific gravity is 2. Okay, this is the answer. Take the screenshot for the future reference. I will scroll down to the next concept. And what are the concept you have to mind it? Uh, Doing solving buoyancy problem, a weight of the water is equal to density of water gravity into volume. This is the weight formula, right? In equilibrium conditions, the weight in air of body is equal to weight in water plus weight weight of the water displaced. The water displaced. What's the difference between these two things? So ஒரு பாடியை வாட்டரில் இமர்ஸ் பண்ணும்போது it will show some weight in a spring or in our gauge. So this is gauge weight in the presence of water, and this is the weight. It's a actual weight of the water is displaced, right? So this is the equilibrium conditions. By using these relations, we can calculate the unknown value of the volume of the body, amount of the uh, amount of the weight of water displaced, and how much height is submerged in water, and also we can able to find out the center of the buoyancy, right? So center of buoyancy is equal to buoyancy is equal to submerged height. This is submerged height to to hmm, the half of the submerged height. அதெல்லாம் வந்து நமக்கு என்ன இருக்கும்? Center of buoyancy locate ஆயிருக்கும், right? ஸோ இதுலேருந்து ப்ராப்ளம் ரொம்ப சிம்பிளாக கேட்பாங்க. So we don't want to go in depth manner in these topics. Now we will plan to move another topic, that is meta center. What is meta center? It's the center through which the body starts oscillating continuously. That kind of center is called as meta center. The meta center will speak only floating body. In case of submerged body, we will speak about the buoyancy center of buoyancy, right? So meta center is in only floating body, and the center of buoyancy in submerged body. So both the case we will have the equilibrium condition, non-equilibrium condition, and stable equilibrium, and unstable equilibrium, and neutral. So these three conditions exist. So first of all, we would like to know one by one. Right. This is the body submerged in water. Uh, the body start oscillating through this axis. About this axis. So according to the small disturbance is given by as some other external forces. Right. Before that, we want to know this point. The meta-center may be also defined as a point at which the line of action of force of buoyancy will meet the normal axis of the body. When the body is given small angular displacement, the body is given a small angular displacement, that is theta. Okay. Let the bo- let the body is given a small angular displacement in the clockwise directions. The center of buoyancy, in which is the center of gravity of the displaced liquid, or the center of gravity of the portions of the body submerged in liquid, will now be shifted towards right from the normal axis. Right from normal axis. Let its B1 is shown. Right. The line of actions of the force of buoyancy in the new positions. First, the position is occupied in normal axis, and now the position is occupied in new position, new point. Will intersect at normal axis point of M, that is called as meta-center. For initial case, the body in stable positions, the both meta-center and center of gravity of body and center of buoyancy in normal axis only. If the body is tilted in small angle, the center of gravity remains in stable position, but the center of buoyancy will be shifted towards right positions due to the amount of submerged volume of body is changing. So that's why the buoyancy forces is depends only on the displaced volume of the liquid. So the center of buoyancy is centroid of displaced liquid. That's why the point is changing continuously while oscillating the body. Now, these 2 points, the normal axis and buoyancy forces axis will intersect at particular point. That point is called as M, and that M is called as meta-center. In analytically, we have to calculate the meta-center by the relations of metacentric height, the distance of mg, the distance between the meta-center of floating body and center of gravity of the body is called as metacentric height. G to M. G to M. This height is called as metacentric height GM. Metacentric height GM. So this is the relations. GM is equal to I by V, that is submerged volume, minus the distance between the buoyancy and center of gravity. So, distance between buoyancy and center of gravity. Center of buoyancy and center of gravity, right? Okay, that's a very important formula. You have to remember, keep it in your mind. It's very important formula. By using these relations, we can able to find out remaining things. Conditions of equilibrium of floating and submerged bodies. A submerged or floating body is said to be stable if it comes back to its original positions after the slight disturbance. Right. The relative positions of the center of gravity, center of buoyancy of your body determines the stability of the submerged body. The two factors is define the whether the body is stable or unstable equilibrium of the body. If they're stable, the center of buoyancy and center of gravity should be in same position. Right. Stability of submerged body. The positions of center of gravity and center of buoyancy is in case of completely submerged body are fixed. You have to keep in mind difference between submerged body and partially submerged body. If the body is completely submerged, for example, for example, this is the container. It's contained it's a full amount of liquid, right? The one body is completely immersed, as like this. Some of wooden block. It's not a wooden block. It's a iron piece. Take an example of iron piece. It is completely submerged in water. In this case, the center of buoyancy and the center of gravity remains in same position, or it is fixed one. In case of partially submerged body or floating body, the center of buoyancy and center of gravity of the body and remains uh, different positions. Okay. Consider a balloon. If it is completely submerged in air, let the lower position of the balloon contains heavier material, right? So that the center of gravity is lower than the center of buoyancy as shown in the figure. Have you got idea? The lower position of the balloon contains heavier material, right? So that center of gravity is lower than the center of buoyancy. Let the weight of the balloon is W, and weight W is acting through G vertically in downward direction, while the buoyant force F is acting vertically upward through B. For the equilibrium of balloon, the weight and buoyancy forces will be equal. The balloon is given in angular displacement in clockwise direction as shown in figure 1. Then the W and buoyancy force F constitute a couple according to the anti-clockwise direction and brings the balloon into original positions. Thus the balloon in the positions is in stable equilibrium. First one. This is the stable equilibrium. This is unstable. If you are tilting the balloon like this, it will automatically comes to these positions, stable equilibrium position, due to the higher weight is present at the bottom of the balloon, this area. So the center of gravity is here and buoyancy force is here. If the weight of the body is higher, what will happen? Uh, these two positions will be interchanging one. Okay. Stable equilibrium அப்படின்னு எப்படி இருக்கணும்? Buoyancy forceம் weight of the bodyயும் equal இருக்கணும். And the point B is above G. The point B is above G. The body is said to be stable. Unstable, buoyancy force is equal to weight of the body, but the center of buoyancy is below the center of gravity. This is the unstable one. This is unstable one. A slight displacement to the body in the clockwise directions gives the couple due to W and F also in the clockwise directions. Thus the body does not return to original position and hence the body is unstable equilibrium. I think you may got the idea. Okay, stable equilibrium. The buoyancy forces and weight of the body is also equal, and B and G are at the same point, that the body is said to be neutral equilibrium. Okay, this is this whole concept is for submerged body. Submerged body. Stability of floating body. In this case,
அதுதான் நானும் முக்கிட்டு இருக்கிறேன் இங்க வரமாட்டேங்குது வரேன்
stability of floating body. The floating body will be like this. So body, the body will float. The half of the volume in water and the remaining half of the volume in air. The body is continuously floating. It will not submerge it. It's the idea behind this, right? The stability of floating body is determined from the positions of the metasender. In case of floating body, the weight of body is equal to the weight of the liquid displaced. Weight of the body is equal to weight of the liquid displaced. Right. In case of stable equilibrium, if a point M is above G, the floating body will be stable equilibrium as shown in the figure. And slightly angular displacement is given. Floating body in the clockwise direction, the center of buoyancy shifted from B to B1, as like we have discussed in earlier itself, B to B1, such that the vertical line through B1 cuts the M. Then the buoyancy forces FB through B1. The weight of the body W through G constitute a couple according to the anticlockwise directions, thus brings the body returns to original positions. This concept is discussed in earlier itself. Mhm. Unstable equilibrium is like the meta center is here. This is a body. The meta center is here and center of gravity is here. This is a stable equilibrium. If the point is changing, in center of gravity is below the sorry, a meta center is below the center of gravity, that condition is unstable equilibrium. Neutral equilibrium, the point of meta center and center of gravity of floating body will be in neutral equilibrium. Now I have the one video.
Good news for those who underline while reading. Did you ever struggle reading on the web as you can't underline?
And you put your index finger inside it. Say you have a beaker filled with water and you put your index finger inside it.
Just listen this video carefully. This is a basic concept of Archimedes principle. Just watch.
Say you have a beaker filled with water and you put your index finger inside it. You'll observe that the water level rises slightly. You put in 2 fingers, the water level rises a bit more. And now when you put in your hand up to the wrist level, you'll see that the water level increases significantly. The ancient Greek mathematician Archimedes observed something similar when he got into a bathtub. When he got in, he realized that the level of water went up. In both the cases, you notice that the water is displaced by the object that goes in. Keep this thought in mind. We'll come back to it soon. In our previous videos, we've seen that when an object is placed in or on the fluid exerts a buoyant force on it which acts upwards. The Archimedes principle goes just one step further in saying that the buoyant force applied by the fluid is equal to the weight of the displaced fluid. We can take a simple example to understand this. Take a 5 kg solid object and suspend it by a spring balance. The balance will read 5 kilograms. Let this be the first case. For the second case, take a beaker of water which has a small opening at the top. The water in the beaker is filled right up to this point where the opening is. And we keep a small container under the opening. Now slowly lower the solid object into the water and you'll see that the reading will be lower number as compared to the previous case. Why is that? It's because of the buoyant force acting on the object. You have also noticed that some water was displaced. Now in this context, we can say that the weight of this displaced water is equal to the magnitude of the buoyant force acting on the object. That's the Archimedes principle. When an object is immersed fully or partially in a fluid, the upward force applied by the fluid on the object is the same as the weight of the fluid displaced by the object. Where is this principle applied? Can you think of examples? How do you think large steel ships float? It's simple. If the weight of water displaced by the vessel below the keel is equivalent to the vessel's weight, then everything above the keel will remain afloat. That's because the water too applies an upward buoyant force on the ship, which is same as the weight of the water displaced by it. There's just one important concept left in this section, and that's relative density, which we will cover in the next lesson.
Now we got the clear idea about the Archimedes principle, the buoyancy forces. Now we will shift on to the problem based on the metacenter, finding the height of metacenter. Right.
result of